Hey Maroons, today we're looking at lesson 7.4 in college algebra. We're looking at 3 lessons in chapter 7. Today we're talking about simplifying radicals on college algebra with Mr. Forbes. Notes out and away we go. So to give an introduction, we're going to look at some example problems to remember how to simplify radicals. Number one, we recall that when we're going to square root, right? Notice there's always a 2 there, and that's why it's a square root. And what allows us to square root 4 is the fact that 4 is actually a perfect square. And so this is actually the square root of 2 squared. This number is called the index, and this number is the power. When the index and the power are the same, they cancel, leaving us with 2. And so that's how we square root 4. Well, let's look at number 2. What happens if we try to square root 8? Well, 8 is 2 cubed. And again, we can just do that on our calculator, divide out 2's, and there's 3 of them. But because it's a square root, only 2 will cancel. So we can actually rewrite this square root of 2, 2 squared, square root of 2. This one cancels, this one does not. So we end up with 2 root 2, not a decimal. None of these answers are going to be decimals, so they're all going to be roots. Then we can look like something like at 3. A couple ways to do this one. So root 32, right? The old way would have been to say, what's the biggest perfect square in 32? And you can still do it this way. This is root 16 times root 2. That's 4 root 2. We're going to think about this another way. And that is to say root 32 is actually 2 to the 5th power. And then every power of 2 comes out. So square root of 2 squared comes out, square root of 2 squared comes out, and we have left with 1 square root of 2. And that's 2 times root 2, which is 4 root 2. And again, you can shorten that process by skipping some of those steps, would be fine. But that's the process of how that works. Another way to think about this, square root of 2 to the 5th power. We know every 2 come out, so we could call this root 2 to the 4th power times root 2. And then actually what's happening here is a division. It's 4 divided by 2. That leaves us with 2 squared root 2, which again is 4 root 2. So a bunch of different ways to think about this. It's important to think about these different ways because when we get to these with variables, we have to know how the rules work. All right, let's look at the same thing with cubed root. So now we have a cubed root, and we know that because the index is now a cube. So what about the cubed root of 8? Well, again, 8 is 2 cubed. Because the index and the power are the same, that just makes it 2. What about number 5? Cubed root of 16. Well, 16 is, we want that in exponential form, 2 to the 4th power. Every 3 exponents now will cancel. So I'm going to rewrite this as the cubed root of 2 to the 3rd times the cubed root of 2, really 2 to the 1st, but that's the same. This one becomes just a 2. The index and the power cancel. This one has to be left inside the root as the cubed root of 2. And we could do that with any root, 4th root, 5th root, 6th root, on up. What about the cubed root of 81? Well, if you play around with the calculator, you know that 81 is divisible by 3, and you actually get 4 3's. So this is the cubed root of 3 to the 4th power. 3 of them will cancel. 3 powers will cancel with the index. So 3 to 3 to the 3rd times, there's 1 left over. That's the 3rd root of 3. Again, this one will cancel. So this is the cubed root of 3 cubed is just 3. And the cubed root of 3 has to stay. Note if it's any other root, 4, 5, 6, we draw the number. If it's a square root, That 2 is optional. So there's a review of how to simplify radicals before we start in on our lesson. And here we go. We're looking at quotients, powers, and rationalizing denominators with simplifying radicals. It is proper form to not have a radical in the denominator. So we want to get any square roots out of the denominator. So letter A, how can we do that? We're going to multiply the top and bottom by the root. Multiply the numerator and denominator by whatever the root is. And I'm going to put it in here because it doesn't have to be a square root. It can be a cubed root or a fourth root. For example, letter A, we're just going to simply multiply the top and bottom by root 5. Because they're the same index, we can multiply inside the roots, and that is the square root of 15 over the square root of 25, right? 3 times 5 is 15, 5 times 5 is 25. Square root of 15 will not simplify, so it just stays square root of 15. Square root of 5 does, and that's a 5. Note, whenever we're just simplifying radicals, we're going to use the principal root, which is the positive. If we're solving using the square root, then it has to be plus minus. So you might be thinking all these have to be plus minus. That's not true because we're not solving. In the next lesson, when we start solving, then yes, it does have to be plus minus. Letter B, we're going to use the same thing, but now we have a cubed root. This is a 2 to the first. To get this cubed root to cancel, we have to have a power of 3. Right now we only have a power of 1. So what do we have to multiply by to get a power of 3? Well, we have to not only multiply by a 2, we have to multiply by a 2 squared. So this turns into a cubed root times 2 to the cubed power. So we have to multiply by as many powers as we need to equal our index. If we multiply it on the bottom, we have to multiply it on the top. Cubed root of 2 squared. So that's going to be 3 times the cubed root of 2 squared. Bottom, we're going to simplify the cubed root of 2 cubed. That's just 2. On the top, we have a 3 times the cubed root, and we'll go ahead and multiply out that 2 squared, which is 4. So simplifying radicals, we can't have radicals in the denominator, so we're going to rationalize by multiplying by the power. Letter A, sometimes we have some choices. So there's a couple ways we can do this one. The easiest thing to do would be just to multiply top and bottom by, again, the same radical, root 6. And if we do that, then we get root 60 over square root of 36. Well, square root of 36 is 6. Root 60, what's the biggest perfect square in 60? That's 4. So that's square root of 4 times square root of 15, which is 2 square root of 15 over 6. And then the 2 and the 6 simplify. It's leaving a 1 and a 3. So our answer is the square root of 15 over 3. There's actually another way to do this one. Because these have the same index, we can actually simplify first. So we can actually think about this as being the square root of 10 over 6. Each divides by 2, leaving the square root of 5 over 3. Now we can rationalize by multiplying the top and bottom by root 3. And we get root 15 over 3, which is our answer. Letter B, we have the cubed root of 5/9. We have a rule that says if we have a cubed root of the whole fraction, we can actually just take the cubed root of the numerator over the cubed root of the denominator. And I'm going to change that 9. 9 is actually 3 squared. Now again, to get the cubed root to cancel, we need a power of 3. We need a cube. We don't have a cube. So what cubed root do we have to multiply to get that to be a 3? We have to multiply by a cubed root of 3. So in our denominator, we get a cubed root of 3 cubed, right? 3 squared times 3 is 3 cubed. In the numerator, we have the cubed root of 5 times 3. That's going to be a cubed root of 15 over the cubed root of 3 cubed. The cubes cancel, leaving just a 3. simplifying radicals with a cubed root. We can also simplify radicals with variables. So it's important we know the rules so that we can use variables. We're going to do the same thing. Just think of the letters as numbers, and we're doing the same thing. So square root of a, square root of b, again, we can actually split that up to be the square root of a over the square root of b. To rationalize, we're just going to multiply the top and bottom by root b. That gives us the square root of b over the square root of b squared. Because this is a square root, the square and the index are the same. That cancels, leaving us with the square root of ab over b. Letter B. So there's a couple ways to do this one. So we'll do this one a couple different ways. First, note that this is the square root of x cubed over the square root of y to the fifth. So one way we can do this is, again, we can multiply the top and bottom by the same root. So I'm going to multiply the square root of y to the fifth, square root of y to the fifth. Now there's going to be a lot of simplifying if we do it this way. So in the numerator, we have the square root of x cubed, y to the fifth. In the denominator, we have the square root of y to the 10th. Now in the numerator, we want to take out every 2 powers of 2. So what's going to come out is going to be the square root of x squared. We have 1x left, so we split that 3 into a 2 and a 1 because we're dealing with square roots. The y's, we can take out 2 2's, which is a 4, and we have 1 y left. So I split that up into powers of 2 and what's left over. These ones will square root, these ones will not. Square root of 10, all of them will square root. And so we have square root of x squared is x. There's 2 square root of 2's here, so y squared, square root of xy, all over, that was to the 10th. So 10, 2, there's actually 5 2's in the 10, so that's y to the 5th. And we're still not done because we can simplify y squared and y fifth as y cubed, so our final answer is x square root xy over y cubed. Kind of a long problem. How can we make that a little bit easier? Well, we can actually simplify the radicals first. So if we start with square root of x cubed over square root of y to the fifth, this is square root of x squared, square root of x, over square root of y to the fourth, square root of y. So we're going to simplify these first to get x square root of x over y squared, square root of y. Now we can rationalize by multiplying by square root of y. And we get x square root of xy over y squared times square root of y squared, which is x square root of xy, over square root of y squared is y times y squared is y cubed. So whichever one of those methods makes more sense to you, you're welcome to do it that way. Either go ahead and rationalize the whole denominator or simplify first and then rationalize the denominator. Letter C, cubed root. So we have a cubed root of x over a cubed root of y. To get a cubed root of y to simplify, we need a power of cubed. What do we have to multiply to get a power of cubed? We need a y squared to get a y cubed. So we're going to multiply by a y squared. That gives us on the top the cubed root of xy squared. On the bottom, we have a cubed root of y cubed, which is y. Simplifying radicals. Why do we need that? Well, we need to simplify radicals because we can divide radicals. First, we're going to look at dividing radicals with the same index, the same root, right? So again, these are 2's. We just don't write the 2 because we use it so often. So one way to think about that is just make it root 10 over root 5. There's our fraction. Now this one has a shortcut. You could rationalize, but notice that we can actually just do square root of 10 divided by 5, which is square root of 2. There's our square root of 2. Letter B, same thing. We're just going to turn this into a fraction. 3 root 2 divided by 2 root 3. And we just want to rationalize the denominator. So we're going to multiply by root 3 over root 3. That's going to give us 3 root 6 over 2. Root 3 times root 3 is root 9. Square root of 9 is 3, or 3 squared. The index and the power cancel, leaving a 3. Notice we can also simplify. The 3 cancels, leaving square root of 6 over 2. We can never cancel anything inside a root with something outside a root. It either has to be both outside or both inside. You can't cancel outside and inside. Letter C, we can do the same thing with the cubed root. Again, we're going to rewrite this as a fraction. The cubed root of 10x squared divided by the cubed root of 5x. And again, this we can rationalize the denominator, but notice 10 is divisible by 5, x squared is divisible by x. So I'm going to rewrite this as a big fraction, 10x squared over 5x, and that's the cubed root. 10 divided by 5 is 2, x squared divided by x is x. Again, you can rationalize the denominator there, but because I saw that those actually divided, we can just turn it into a big root. We can also use the strategy of simplifying before we divide. How does that work? So this is root 12 divided by root 72x. I note that 12 and 72 have common factors. So I'm going to turn this into a giant square root of 12 over 72x. If I divide 72 by 12, I actually get the square root of 1 over 6x. So there's our simplify first. Now we're just going to come back and rationalize. I'm going to split up the square root numerator and denominator. The square root of 1 is just 1. Then we have square root of 6x in the denominator. Now I can rationalize by multiplying by square root of 6x. And that gives me square root of 6x over 6x. Letter B, here we see a fourth root. A fourth root. So again, we can look to divide first. So we have the fourth root of 16a all over the fourth root of a to the fifth. I notice that the a's will simplify, so I'm going to turn that into a giant fourth root first. 16a over a to the fifth. 1a cancels, leaving 4. That leaves me with the fourth root of 16 over the fourth root of a to the fourth. 16 is actually 2 to the fourth, so that leaves me 2 over a. And you actually have all of those roots on your calculator. And to do that, we're using the button that is the xth root. And if we go to math, we actually have a cubed root and an xth root. Again, remember your answers have to be in radical form. But for example, if we wanted to do that problem, we do 4 square root of, or the fourth root of 16. And again, that will give you 2. All right, next step. We're looking at simplifying. This is a skill we're going to need when we solve radicals or solve polynomials. 4 minus root 12 over 4. So we're going to break this up to be 4 over 4 minus root 12 over 4. This is the 1. Notice 12 simplifies. 12 is the square root of 4, square root of 3. And the square root of 4 is 2. So we actually have 2 root 3. So let me rewrite that. So now we have 4 over 4 minus 2 root 3 over 4. And now we can simplify. 4 divided by 4 is 1. 4 divided by 2 is 1/2. So we have root 3 over 2. Letter B, we're going to do the same thing. We're going to break this up to make it -6 divided by -2 plus root 20 over -2. Let's go ahead and simplify root 20. That's the square root of 4 times square root of 5, which is 2 root 5. We can do the divisions. -6 divided by -2 is 3 minus, positive divided by negative is negative, minus. The 2's cancel, leaving root 5. Next thing we're going to talk about is a conjugate, because we're going to look at simplifying one where there's a number and a root. How do we do that? Well, we have to use the conjugate. A conjugate is for a rational number in the form a plus root b is the opposite. Root a minus b, a minus root b. So a plus root b, a minus root b, those are conjugates. So we just flip the sign. So how are we going to do this? We're going to rationalize the denominator by multiplying. The denominator, we're just going to multiply by the conjugate. The conjugate is 4 plus root 3. And we're going to see what happens. Basically, we turn this into a sum and difference pattern, so the roots are going to cancel. So in the denominator, the roots have to always cancel. We're going to FOIL this. This is 8 plus 2 root 3 plus 4 root 3 plus the square root of 9, which is 3, all over. 4 times 4 is 16, plus 4 root 3, minus 4 root 3, minus square root of 9, which again is 3. Notice, why do we do that? What happens? The outside and the inside cancel, the O and the I. So these cancel, leaving us with 16 minus 3, which is 13 in the bottom. In the top then, we're going to put the number first. 8 plus 3 is 11. 2 root 3 plus 4 root 3 is 6 root 3. So there's our simplify. Same thing with letter B. We want to rationalize the denominator. To do that, we're going to multiply by the conjugate. Here the conjugate is root 6 minus root 2. If we multiply it to the bottom, we have to multiply it to the top. And so let's do that multiply. In the top, this is just distributive property. Root 5 times root 6 is root 30. Root 5 times root 2 is root 10. All over. Now we're going to FOIL. Root 6 times root 6 is root 36, which is 6. Root 6 times minus root 2 is minus root 12. Root 2 times root 6 is plus root 12. Root 2 times negative root 2 is minus root 4, which is minus 2. What happens? 30 and 10 do not have any perfect squares, so that just stays root 30 minus root 10. And then on the bottom, what happens? The O and the I again cancel, and we have 6 minus 2, which is 4. And finally, let's look at simplifying with exponents. So recall, how do we do this? Well, power to a power, a to the m to the nth power is a to the mn. We're just going to multiply. Everything gets the power. And so 5 has a 1, 2 has a 1. This becomes 5 cubed times the square root of 2 cubed. We know that every 2 powers of 2 come out because the index is a 2. So this is 5 cubed times the square root of 2 squared times square root of 2. I'm going to break this up into a 2 and a 1 because the 2 cancels. The index of 2 and the power of 2 cancel. So we have 5 cubed times 2 times root 2. We can work that out on our calculator. 5 cubed is 125 times 2 is 250 square root of 2. Again, no decimals, although you can use your calculator to check it by seeing if the decimals are the same. There's our process. Same thing here with a 4. 2 is a 1, x is a 3. Everything gets a power of 4. So this is 2 to the 4th times the square root of x to the 12th. Because this is an x to the 12th, another way to think about this is 2 to the 4th. This is the square root of x to the 6th squared. And so the index of 2 and a 2 actually cancel. It's actually a division, 12 divided by 2. So we get 2 to the 4th, which is 16, and then x to the 6th. Letter C, again, everything gets a power of 3. This is 3 cubed. The 3 is the index, not the power. So this is 3 cubed w cubed to the cubed root of 2 cubed w cubed. Well, here the index and the powers are the same. So that cancels the root. So we have 3 cubed times w cubed times 2 times w. We can simplify that. 3 cubed is 27 times 2 is 54 w to the 4th. And lastly, everything gets a power of 3. 2 cubed t cubed, the 4th root of 3 cubed t cubed. Here, the 4th root, the power of 3's are not big enough to cancel. It has to be a 4. It's not irrationalized, so we're not adding anything to it, so actually nothing happens. That just stays as the answer. 8t cubed, the 4th root. Now we are going to multiply this out. 27t cubed. That's our answer. And for homework, we're working on lesson 7.4, page 488, 2 through 24 evens, 30 through 40 evens, 46 through 56 evens, 60 through 68. Have a good day, Maroons. See you in class.